Hello everyone, this is the first video for my YouTube channel as well as for the course Basic Mathematics for freshman students. And the first question for the first chapter of the course is on tautology, contradiction and contingency. So the first states that determine whether the following statements are tautology, contradiction or neither. We know that in order to check whether the given compound statement is tautology or contradiction, we have two different techniques or methods. The first one is using truth table or preparing a truth table, and the second one is without truth table, just by considering the properties of the logical connectives. So let us let us check these compound statements by using the first method, that is using truth table. So let us start from the first one, that is A. Here we have two simple statements P and Q. The second component statement is Q implies P. And lastly, the given compound statement, that is P implies Q implies P. The possibility for the truth values of its component statements are both P and Q can be true. The first P may be false and second one is true. Both can be false. The first may be true and second may be false. So that depending on the truth values of P and Q, Q implies P would be true implies true is true, true implies false is false, false implies false is true, false implies true is true. And here the truth value of the given compound statement will be, in order to fill this column, we have to consider the first column and third column. So that true implies true is true, false implies false is true, false implies true is true, true implies true is also true. So that, as we clearly observe from the last column, the truth value of the given compound statement is always true, whatever the truth values of the compound statements P, Q and Q implies P, and here's the property of that of the tautology. Tautology, therefore, since it is always true, the compound statement P implies Q implies P is a tautology. The second question, that is B, it is P and Q implies, P or Q implies P and Q. Again, using the same technique, that is using truth table, we have the component statements first P and that of Q, and next one is P or Q, P and Q, P or Q implies P and Q. Both P and Q may be true. This is true and false, 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 true. So that depending on these truth values, P or Q will be true or true is true, and this is true, false, then true. P and Q, true and true is true, this is false, false, we have false. So that's the truth value of this logical implication or this compound statement will be. Its truth value will depend on these elements. So that true implies true is true, and this is false. False implies false is true. True implies false is false. Therefore, in some cases, the truth value of the given compound statement is true, and for the other case, it is false. This makes it so that the truth value of the compound statement is not always true or always false, so that the compound statement is neither tautology nor contradiction, Therefore it is a contingency, a statement which is neither tautology nor contradiction. The other second question is also on the same idea, that is tautology and contradiction, but with a new approach or simply different approach. It says, without truth table, prove that the following statements are tautology, contradiction, or not. So let us start from the first one. That is P and P implies Q implies Q. We know that this statement, that is P and P implies Q could be equivalently written as the negation of P and negation of P or Q negation of P or Q, that is in the inner, or this one, that is Q, since P implies Q is equivalent with negation of P or Q. Then again, this is equivalent to the negation of P and negation of P and or Q. In clear form, that means. Then when we distribute this negation over the compound statement which is enclosed by the outer bracket, the heat equivalent with the negation of P. Conjunction must be changed into disjunction. Then a negation of negation is positive, that is P, so that this must be changed into negation. And then negation of Q or Q. Again, this is equivalent with distributing this one over using distributive property of disjunction over conjunction. They hit the same as the negation of P or Q and negation of P or negation of Q or Q. But we know that negation of P, sorry, this is P, negation of P or P is true because at least one of these two compound statements are true. And this is connected by conjunction with this one, so that totally the truth value of this compound statement will depend on the truth values of this one. Therefore, they hit equivalent with the negation of P or negation of Q or Q. Then using associativity property of disjunction, they hit equivalent with negation of P or Q or Q. This is always true, so that they hit equivalent with negation of P or true, which is equal to which is always true. Therefore, since the truth value of the compound statement is always true, whatever the truth values of its components are, therefore the compound statement is a tautology. The second one, that is B, which is P and negation of Q and P and Q. And therefore, everything here is only conjunction with two component statements P and that of Q, so that we can use, or this could be written as P and negation of Q and P and Q is equivalent written as using associativity and commutativity property of this conjunction. I mean, this is P and P and negation of Q and Q. The head equivalent with P and P is P and negation of Q and Q, which is equivalent with negation of P and negation of Q and Q is false. So that whatever the truth value of this one, that simply P here is, since this one is false, this is false. Therefore, the truth value of the given compound statement is false. Therefore, the compound statement is a contradiction. Contradiction. Then the next question, that is the third question, would be this one, that is just justification. It says, let P and data of Q be propositions, then which of the following implies P or Q is false? When we see the first one, that is negation of P or negation of Q is false, for this statement to be data false, both negation of P and negation of Q must be false at the same time. If so, P and Q must be true, so that this doesn't imply P or Q is false, so that it is X. The next one is negation of P or Q is true. That means for this to be true, both negation of P and Q must be true at the same time. That means P is false and Q is true, so that this doesn't imply P or Q is false. Here, negation of P and negation of Q is true. It means for this statement to be data true, since it is a conjunction, both negation of P and negation of Q must be true at the same time. If negation of P and negation of Q are true at the same time, P and Q are false. So that false or false implies false. Therefore, this can imply P or Q is false. Here, P implies Q is true. For this to be true, both P and Q may have the same truth value, or P may be false and Q may be true. So that in this case, this statement may imply this one only when both P and that of Q were false at the same time. Therefore, it may imply this one on only one condition. On one condition. Here, negation of P or negation of Q is false. For this to be false, we know that. By the way, this is repeated here. That is, both negation of P and negation of Q are false at the same time. P and Q are true, so that this doesn't imply P or Q is false. And lastly, P and Q is false. For this to be data false, at least one of these two, P or Q, must be false. So that this logical conjunction will imply this one only when both P and that of Q are false at the same time. Therefore, it may imply this one on one condition, that is when P and Q are false at the same time. The next question, that is question number 4, is this one, that is, it says, show that the following paired statements are logical equivalency. So that in order to show this one, we have the first one, that is the negation of P or negation of P and Q, and negation of P or Q. So that in order to show the equivalency of these two, we can start either from here and arrive this one, or we can start from here and arrive at the first one. For the time being, let us start from the first one, that is here. We know that the negation of P or Q, P or negation of P and Q is equivalently rewritten as when we distribute this one, that is disjunction over conjunction, this is equivalent with the negation of P or negation of P and P or Q. P or Q. Again, the equivalent with the negation of P or negation of P is true, and this one, that is P or Q. Since it is conjunction and this one is true, the truth value of this compound statement will depend on this one. Therefore, the equivalent with the negation of P or Q, which is equivalent with this one. Therefore, they are equivalent. That is negation of P or P and Q is equivalent with negation of P or Q. Second one, that is B, the negation of P or Q or R and P implies Q is given. So that let us start from the second statement and try to arrive at the first one. That means the negation of R and P implies Q is equivalent to written as the negation of R and P or Q. That is, using the property that is P implies Q is equivalent with negation of P or Q. Then distributing this one over here, they is equivalent with the negation of R is, that is R. So that conjunction should be replaced by distraction, that is or negation of P or Q. Using commutativity property and associativity, they is equivalent with, or this can be written as negation of P or Q or R, which is identical with this one. Therefore, negation of P or Q or R is equivalent with negation of R and P implies Q. That is, they are equivalent. They are equivalent statements. The next one is, that is question number 5, which is a question on the validity of arguments. It says use formal proof to show that the following argument forms are valid. Let us start from the first one. That is, P implies negation of Q, R implies Q, P, therefore negation of R. Here we have 3 premises and 1 conclusion, that is, the conclusion is negation of R. Therefore, let us start by from this one, that is, we know that P is true since it is a premise. Then if P is true from here, we have again the first premise, that is P implies negation of Q is true since it is again a premise. So that for this logical implication true, because the if statement that is simply P is true from above here, this implies negation of Q is true. Simplification. Or simplification, or from the first property. If negation of Q is true, this implies Q is false. If Q is false from here, and for the statement that is simply again R implies Q is true, but we already have this one, that is Q is false, so that for this logical implication to be that of true, this implies R must be false. If R is false, negation of R is true, which is the result. Therefore, from this, since the conclusion is true, when we assume that all the premises are true at the same time, so that the argument is valid. Right. The second one, that is B. What we are given here is negation of Q implies negation of P. The first premise. Second one is R implies P. Negation of Q, and the conclusion is R. So let us start from the single statement, that is negation of Q again. We know that negation of Q is true, since it is a premise. This implies Q is false. If Q is false from the first one, negation of Q implies negation of P is true, since it is again the first component, that is a premise. But negation of Q is true, so that for this logical implication to be true, negation of P must be true. If negation of P is true, this implies P is false. But from the next premise again, R implies P is true, but we have P is false here, so that since the conclusion is false here, R itself must be R must be P is false here, so that R is false. That is the conclusion. Therefore, since the conclusion is not true when we assume that all the premises are true at the same time, and therefore the argument is not valid, or it is invalid. Okay, that is all what I have for this video, but don't forget that subscribing, commenting, liking and sharing this video with your friends, and told them to do the same as you. Thank you.